Hello everyone, my name is Ashley Rose Johnson, and today we will be conducting a chi-square test of independence. Our agenda includes an introduction to chi-square tests, our first, second, and third chi-square tests, Cramer's V interpretations chart, key takeaways from the presentation, and lastly, we'll conclude with any questions that you have regarding the presentation. Introduction. So first off, what is a chi-square test of independence? The chi-square test is known as the Pearson chi-square, or simply the chi-square test, and it is one of the most useful statistics for testing hypotheses when the variables are nominal. When should we use the test? The chi-square test should be used when there are two nominal variables, each having two or more possible values. R by C table. This dataset is often used, known as the rows and columns table. Rejection rule. We reject the null when p is less than alpha or where alpha is equal to 0.05. If p is greater than alpha, we fail to reject the null hypothesis. Now there is an exception and an additional rule. If we reject the null and p is less than alpha, we must follow with Cramer's V. Cramer's V tells us how strong the relationship is if we reject the null hypothesis. Now it's time for our first hypothesis test. The following chi-square test was conducted. Null hypothesis. There is no relationship between the number of cars and number of defaults. Alternate hypothesis. There is a relationship between the number of cars and number of defaults. After performing the chi-square test using PSPP, assuming alpha equals 0.05, we know that the test had 9 degrees of freedom, contained 150 cases, and the chi-square statistic was 9.70. The p-value equals 0.375, therefore, no relationship emerged. For our second hypothesis test, the following chi-square test was conducted. Null hypothesis. There is no relationship between the Likert comfort and number of defaults. Alternate hypothesis. There is a relationship between the Likert comfort and number of defaults. After performing our next chi-square test using PSPP, assuming alpha equals 0.05, we know that the test had 9 degrees of freedom, contained 150 cases, and the chi-square statistic was 9.70. The p-value equals 0.375, therefore, no relationship emerged. Moving on to our third and final hypothesis test, the following chi-square test was conducted. Null hypothesis. There is no relationship between the number of cars and Likert comfort. Alternate hypothesis. There is a relationship between the number of cars and Likert comfort. Chi-square statistics and its p-value were conducted using PSPP, assuming alpha equals 0.05. After performing the chi-square test, we know that the test had 9 degrees of freedom, it contained 150 cases, and the chi-square statistic or value was 450. The p-value equal to 0 and had a Cramer's V of 1.0. Cramer's V indicated a perfectly symmetric relationship. Next, we have our Cramer's V interpretations chart. As you can see, it ranges from the strength of association 0.00 to 1.0 to the interpretation, starting from no relationship to a perfectly symmetric relationship, and finally to the comments, starting with there is no relationship to consider to very rare. The independent variable perfectly predicts the dependent variable. Before we conclude, let's go over some key takeaways from the presentation. PSPP actually does all the calculations for you, making it that much easier than manually calculating. Chi-tests are known as crosstabs in PSPP. Chi-tests are performed by using the Analyze tab, then clicking Descriptive Statistics and following with crosstabs, as seen in the photo to the right. Remember to put the correct data in the rows and column sections, then click Statistics to make sure that the chi-square and phi, also known as Kramer's V, options are selected. Lastly, it all gets easier with time and patience. Soon, you'll be able to organize and analyze categorical data to see if there's a relationship between two categories. Thank you everyone for watching. Please direct any questions to our discussion board or in the comments below.